Many developers have heard of MySQL. According to DB engines, MySQL is the second most widely used database management system in the world as of 2024. MySQL does have two brothers, MariaDB and Percona Server. Both MariaDB and Percona Server are known for their unique offerings in the database space. Compared to MySQL, MariaDB offers more data types and storage engines users can choose from, while Percona provides database consulting services and builds some of their own products such as XtraDB, which is an enhanced version of the InnoDB storage engine, and XtraBackup, which acts as a complete and open source online backup solution for all versions of MySQL. MariaDB is also known for its ColumnStore offering. ColumnStore extends MariaDB with Columnar storage, and it is a massively parallel processing, shared nothing architecture that was built by porting InnoDB 4.6.7 to MariaDB and released under the GPL license. If we take a step back and look at it, columnar storage refers to a database that stores data using a column-oriented model. Column-based data storage makes it easier to read columns of data, and that's why it's usually used for analytical applications, but at the same time, columnar databases like ColumnStore raise the cost of doing simple insert operations because they do not operate as row-oriented databases do. With that out of the way, if we would look at the way ColumnStore is designed, we would see that MariaDB ColumnStore is designed for intense reading operations with occasional huge data updates, so we can say that it is a good fit for online analytical processing or OLAP use cases. ColumnStore being MariaDB based means that any SQL statement can involve both tables built on ColumnStore and another storage engine such as Connect, Spider, or the S3 storage engine. Indeed, the default storage engine InnoDB can also be used. ColumnStore is a specialized storage engine to facilitate scalable and high-performance analytics operations with parallel query processing. To create a table running the MariaDB ColumnStore engine, use a create table statement with the engine specified as ColumnStore as shown in this example. After you have created your table, it is time to look at the use cases. Use ColumnStore for anything that requires fast retrieval of columns of data. That includes pretty much anything that falls in the data warehousing or big data categories. As stated before, ColumnStore is perfect for analytical applications, and yes, count queries will be blazing fast too, unlike in the default storage engine offered by MariaDB. To load huge volumes of data into ColumnStore or into any storage engine within MariaDB, you can use the load data in file statement. Unlike inserts, load data in file doesn't have that much overhead, and it is meant to deal with raw data, which means that your queries will complete much faster. In the usual setup, loading 1 million rows into your table should take around 20 seconds, which isn't too bad. That's around 33 minutes for 1 million rows. Also keep in mind that the ColumnStore storage engine has limitations too. To begin with, if you use ColumnStore, it is likely that simple insert operations will be massively slow. By default, ColumnStore can only store 8 bytes of data inside of a column due to its design, and if the value is bigger than that, it is saved in a separate data dictionary and referenced to the corresponding column, and that's the primary reason why checking how much space our data occupies on the disk usually returns next to nothing if our table is running ColumnStore. When it comes to columns, ColumnStore only reads the columns that are necessary to complete a query. That means that to save disk I/O, you should only select the columns that are absolutely necessary for your query to complete. Aggregation operations should also be of concern. Since all of the aggregation is performed in memory, the more complex they are, the more memory they will require. Avoid huge limit operations and anything in that realm. Aim to optimize complex join operations too. Since ColumnStore also performs those in memory, if the join operation is completed on large tables, that can cause issues with the memory of your server. Lastly, for the best performance with integer operations, keep in mind that some operations can overflow the maximum scale or precision set by ColumnStore as well. For that, keep in mind that if you use ColumnStore 5, the maximum precision and the maximum scale is 18, while if you're using ColumnStore 6, the maximum precision and the maximum scale is 38. Enterprise ColumnStore 6 also allows you to set a variable to check for decimal overflows, but that can be done only when the column has a decimal precision that is more than or equal to 18. Coming back to storage, ColumnStore manages the table structure on the disk, but the data is stored using a separate service. That is why MariaDB provides us with a bunch of stored procedures we can use or call to acquire details from the storage engine. The query you see on your screen will return the details about the actual usage of disk space for the specified table. MariaDB will return the table schema, table name, how much space is used on the disk, the size of the dictionary, and the total size of our table as a value of total usage variable. Aside from that, ColumnStore can be used just as you use everything else. Just keep in mind that ColumnStore will store data in columns instead of rows. It is also worth keeping in mind that as far as ColumnStore is concerned, its dictionaries act as another layer of data operations. Subscribe to this channel if you want to learn more about ColumnStore and related storage engines in MariaDB, and until next time.